Good afternoon, everyone. Just a few very short slides talking about what we feel is a really critical matter for drone integration, and that's how a ground-based sensor network can integrate drones with manned aircraft. What's the current situation at the moment? Well, I think we all believe that drone deliveries, inspections and air taxis will undoubtedly transform the way we live our lives. There's no shortage of evidence in this exciting event and many other activities around the world that demonstrate that to be the case. And there's huge amounts of time and effort that's being poured into this process. But there is a big problem that risks the future of the entire ecosystem. And that is that drone vision systems are not good enough by themselves to detect aircraft at the moment. And the risk of collisions requires drone pilots to maintain visual contact, by which we mean visual contact with their drones at the moment. So this is the BV loss, i.e. drones have to fly within visual line of sight, and of course visual contact with other manned aircraft, which are not always particularly easy to see. And without resolving this problem, this whole sector is going to be held back significantly. But there's a couple of key insights that we can draw on that will maybe help us in moving this problem forwards. Firstly, it's important to understand that onboard sensors by themselves won't or are highly unlikely to achieve the required levels of coverage. Generally speaking, regulators are looking for something like 90% of aircraft being seen over urban areas and something like 50% of aircraft being seen in rural areas. So if you look at the JARAS, SORA, the EASA regulations in this area, you have to consistently and reliably see 90% of aircraft in urban areas. Now, onboard sensors can pick up other aircraft, and there's a lot of movement in this technology, but the problem is the consistency. It's also expensive equipment. It's very consumptive in terms of energy on board the drone, and generally speaking, it's too expensive for the operations that we're offering to fit these sensors on board, and that's a key insight. Secondly, you can though replace it with a ground-based sensor network. There's a number of these sensor networks that operate on a non-professional basis or a hobbyist basis at the moment, where they're ingesting aircraft telemetry data, and we can integrate that data and fuse it, bring it together with the drone positional data, which we have through the drone ground control stations, and we can create what we're calling a trusted airspace picture. Effectively, you can see where the drones is, and on your device, you can see where the other aircraft are. What are the benefits of doing this? Well, the key benefits are that they allow us to integrate drones and manned aircraft together. And that's very important. This is something that the regulators like the Civil Aviation Authority in the UK have said will be an acceptable form of risk mitigation. It's something that they're allowed to, they're allowed and minded to approve within UK regulations and presumably in many other regulations around the world. This allows safe separation procedures to be applied, so it's not an entirely technical solution. My background is airspace management and air traffic control, and there will always be a role for a human in the loop, or at least on the loop, and for human procedures to apply, for instance, keep well clear rules and to remove the drones from the path of aircraft if aircraft were, for instance, to come into areas where drones were operating. But those procedures alongside the technology can make the system work. And this means that traffic managers, typically UTMs, can operate with a full airspace picture. And that's really critically important. The question I would ask of the audience and any traffic manager is, how are you going to manage the traffic if you don't know where it is? And I don't just mean the traffic that your UTM is managing. What about the traffic that the other UTMs are managing? Or the traffic that you can't see because it's not being managed by UTM, it's being managed by an NSP because it's manned aviation. So we've got to be careful we don't put the cart before the horse. We actually start by figuring out where all the aircraft are and whether we can see them. So what does this look like in the future then? Well, we've built a solution for this based on ground-based sensors, which you can see in the image. We offer it as free license software, because we believe it should be accessible to everybody. And we combine the sensors, which are aviation antennas, they're existing commercial off-the-shelf products, with apps within the system that connect it via APIs, application programming interfaces. And businesses then can subscribe to the data feeds and can then fly their sensors fly their drones over sensors beyond visual line of sight. And we're setting up a number of zones in the UK and indeed starting abroad now, demonstrating exactly this capability. Key thing is it's built to regulatory standards, so this is a professional network, it's not a hobbyist network. It conforms to international standards, by which we mean cybersecurity, software assurance levels, agreed data and API integration standards, so that everybody is using the same standards, so that everybody can be part of the same network. And there's a patent pending for the work that we're doing. And that's really the message that I wanted to get across. I think it's quite a simple one, but I think it's a very powerful and important one. We certainly have much more detailed presentations which go into how the system works and how it's deployed. And if you'd like to work with us, how we do that. We're a UK, actually London-based organisation, Neuron Innovations. We are all aviators. The founders are drone experts, an airline captain with a software background, and myself from, as I said, an airspace and air traffic control background. So that's the presentation. I hope it's been of interest, and I would be very happy to take Q&A if we've got time for that now.
Thank you, sir, for the presentation. I have a question. The question is, like, if we have a drone classified or let's say identified as a body in the air, and then comes up a aircraft, how are both of them distinguished from each other, and how like we can stop the sky from being clouded by so many drones and aircrafts?
Yes, thanks for the question. It's a very good question. So overall, we're expecting to see a 10x increase in aircraft over the next decade. And those will by and large be drones. So they're different to the manned aircraft that we're seeing now, but we're seeing many, many more platforms. And all air traffic controllers that I know, and I know them fairly well around the world, say that is not something they want to manage. And in fact, they're not even able to manage because they don't normally have HF and VHF voice comms to the pilot. They can't pick up the drones on their traditional radars. And as we know, radars are very expensive. They don't have full coverage anyway. So there are many areas where there simply isn't surveillance to conduct the work. So you have to come up with a new solution, and that's adding antennas in a ground-based network, a mesh network or an IoT network, if you like. And to the question of how do you separate between the aircraft, well, bear in mind we're picking up different data on each of the aircraft. We will normally represent those aircraft according to what they are, so drone icons, aircraft icons, and we can separate between them according to the type of data they're sharing. Just to talk a little bit about this, because this is really the realm of the technology and it's how we do it, but it is important. I think most people know that ADSB, automatic surveillance broadcast dependent, is one of the preferred methods of gathering positional data. That's great. That system does ultimately become overwhelmed, has bandwidth issues, and it's very important that it's made cyber secure, which is what we do. At the moment, it's very easy to spoof that data. But by using multilateration, we can put a fix with 4 or more sensors on an aircraft. This is what the hobbyists do already. And we can know with a high degree of certainty and with cyber security that that is the aircraft we're talking about. And using that information, we can, using that data, we can find out further information about the aircraft. So that's how we do it. Hopefully that answers your question.
Thank you, sir, for the answer.
So one question, Niall, is how do you see this technology getting integrated into the future airspace? Like, what could be the more complicated areas which could be made much simpler with these applications?
Yeah, thanks very much for the question. And it's a good question as well, because I think that's Dr. Rushi's, thank you. This is a change. Okay, this is quite a big change to the way that airspace is managed, but it's not swapping out what currently happens. The existing air traffic control systems will continue and will provide the service that they currently provide to manned aircraft. So that's fine. And we hope, post-pandemic, that we will go back up to the same levels of aviation activity that we had in 2019, and that sector will continue to grow in the way that it has in the past, but on a more sustainable basis. So that will continue, but this layer gets added on top. So the sensors are relatively small, about the size of the palm of my hand. I have quite big hands, but they're not huge. They're certainly not like big radars. And they're in the region of $1,000 a piece, and they're commoditizing down to perhaps half of that cost at the moment. There's not really a big market for them. The obvious place to put them is on masts, because they've got height, they've got power, they can connect to the Ethernet. So infrastructure like mobile telephone masts are the obvious place to place the antennas on. In terms of the distribution of them, it's very much ground dependent. Obviously in hilly terrain, as many people with a military background will know, setting up radars and these sorts of things, it's much more complicated than desert or flat terrain. But in principle, we're looking at about every 10 kilometers, which resonates with how mobile networks are currently deployed, at least 3G, 4G. They can be on other infrastructure as well, so you can think of airports and clubs, gliding clubs, etc. There's various ways of deploying them publicly, privately. It will ultimately become a business in its own right, because the financial model pays for every time these sensors are used. So there will be a business in providing a sensor network, and it should be a fairly profitable business. We've modeled payback periods of about 18 months, and we would expect the antennas to last at least 10 years. So that the network gets deployed, and then from a regulatory perspective, this is where the change is coming through. At the moment, they would be in areas which are known either as transponder mandated zones or sensor mandatory zones in the UK at the moment. And there are similar regulations around the world. So it's a set-up zone for the use of drones, but other aircraft, so long as they're transponding. We anticipate the mandation of electronic conspicuity in the UK in 2024-25, which means all aircraft will have to transpond their position. And then it really opens the airspace up to do this on a much wider basis and not just in zones. So it will be a stepping stone approach via zones and via ground-based network deployments. But ultimately, we see the whole airspace changing, or at least the unsegregated airspace changing to this way of working. Obviously, segregated airspace around airports, etc., slightly more complicated, will follow necessarily a more restrictive set of rules, but we'll still use the same technology. Hopefully that's a good answer.
Thank you. So we have another question from a participant. How do or where do we install radars in urban areas where more people are around? And does the ground-based sensor network are they 100% reliable for safety?
Yeah, so it's a good question as well, because I think we generally have to distinguish between urban operations and rural operations. We're dealing with a number of hazards here. There's the air-to-air hazard, which we're familiar with, and it's really the crux of the issue. The regulator isn't confident that the air-to-air hazard is properly managed at the moment, hence the restrictions that we work under. But there's also a ground-based hazard as well, in the event of aircraft having to land in an emergency, or even, God forbidding, that there's a crash or similar, that there will be a ground-based risk, which is much higher in urban areas. And I think this is a key planning factor for things like urban air mobility, so air taxis in urban areas and flying over populated areas as opposed to roads and rivers, etc., where the ground risk can be mitigated to a certain extent. That said, as we move to 5G technology, 5G antennas are actually much closer together. They're more like 500 meters than 5 or 10 kilometers. So there will be plenty of placements on roof-based masts where we can put these relatively small antennas. They're not big radars, so there's not a big risk. In fact, they really represent no risk either from a radiation or from a falling to the ground hazard perspective at all. So the only real issue, and it's not a trivial one, is flying in built-up areas. So the wind turbulence issues around high-rise buildings, the intervisibility, obviously, if you have block lines of sight, and the general requirement not only to have a more dense network, so you've got very good coverage, but I suspect regulators will need backup through things like 5G for command and control systems, that type of thing. And that's a whole process that's being worked through at the moment. But from a risk perspective, there's no additional issue with our solution in urban areas, and that's the key point.
Thank you so much, Niall. And how far do you think in the future are flying cars? So,
that's another very good question, and we're all quite excited to see them coming about. I think the Chinese are very keen to be the first down to the gate with EHang. There's talk about certification. I don't know whether it's passenger carrying for sightseeing or whether it's just cargo carrying, but it will become passenger carrying in due course. I know Archer in the US are chomping at the bit and getting pieces of certification through. I also know and there's some very, very good companies, both here in the UK and the US, of course. Vertical aerospace in the UK is making great strides and really attracting market interest. Joby and a number of other American contenders just look very strong propositions to the market. And even the big players like Hyundai, who have obviously infrastructure, which not everybody knows, but also automotive manufacturing on a large scale behind them, each have a different approach to the market. So I think the short answer is actually very soon. We'll start seeing more and more air taxi activity on a trial basis, on initial certification basis. There may be certain use cases in safe areas like sightseeing overseas or river areas, coastal areas, that type of thing. And we'll build up from there. But I think the interesting thing is going to happen when we see manufacture at scale and when we see approvals where the safety levels allow, this real intra-urban operation where we've overcome where the vertiports are coming, and there's some super exciting solutions there with things like urban airports. I think the first one we're getting is in Coventry in the UK. In the new year, a modular-based approach, and several of the others from people like Skyports, etc., who have already had installations in places like Singapore. So people are going at different speeds for slightly different solutions, but I think we'll start seeing it very soon. These guys actually need to be able to see the other aircraft as well, because remember, there'll be a lot of drones up there by the time they're flying. And I think we're going to see a very, very different sky when we look up in the near future. And that's a fantastically exciting prospect.
Thank you so much, Niall, for a very interesting presentation. And we look forward to hearing more often from you on our platform and learning from you. And we really hope we can be a part of your solution someday and help you scale up your applications. Thank you so much for being a part of the conference.
Thank you for inviting me. It's been a pleasure.